Okay, here's a nice geometry example. We have a circle that's inscribed in a regular pentagon, and the regular pentagon's edge length is 19 inches. We are to note that OA is the radius of the circle in the figure that we're given. And we're to find angle AOB in degrees, the length OA in inches, and ultimately the area of the circle in square inches. Now, I would like to make a note that when you see the word regular for any polygon, it means all the sides are equal, which also means all of the little vertex angles are the same, and you get lots of nice symmetry when you're talking about a regular polygon. Okay, so keep that in mind. Now, if we're looking at your circles, and you have to excuse me, I'm a little hoarse today. If you look at your circle's radius, okay, we're going to focus here, and then the angle AOB is this guy. Okay. Now, a couple of things I'd like to know just in general, and then we'll see what we need to use here, is that these radial lengths are all equal. When you draw from the center of the circle to each vertex, we have 5 equally sized central triangles. Okay? And since that is the case, let's just take any one of them. Note the central angle theta would be 360 degrees divided by 5, so there are 5 total, or 72 degrees. Now OA drops a perpendicular, it's a point of tangency, and therefore AOB would have to be 36 degrees. Okay, these two would be equal, and total 72 degrees. Okay, so we know that angle AOB is 36 degrees. Note that we don't put the degree symbol inside. The units are already noted for us outside the box. Okay, now if you want to find OA, noting that the entire side length of this regular pentagon was given to us as 19, we note from geometry that when we drop a perpendicular between two equal sides, we also bisect the base. Okay, so each of these are half of 19. Okay, and you can notice that if you want to find OA as far as the triangle goes, and let's draw it again here. Here's A, here's B, here's O, and here's what we know. So OA is actually adjacent 36 degrees, and AB, the side that we know is opposite 36 degrees. We have the calc pad available, so we can just as conveniently use cotangent as we could tangent. And I'll use cotangent because it puts OA in the numerator. You could use tangent, takes just one more step in the algebra. And so we have adjacent over opposite. And so OA is actually 19 halves cotan of 36 degrees. And because we were told in the problem that we could type things in symbolically, we can leave it like this. Okay, but again, you could have used tangent. It's totally fine. Okay, now you want the area of the circle. Well, the circle's radius is OA. So the area is pi times its radius squared. So we would have pi times the value we just found for OA, quantity squared, I would not bother simplifying it. And we're good to go.